Alright folks, this video is going to cover optimization problems. So this is 9A and B on your Unit 2 concept list. Okay, so first thing we want to do is read all the way through and point out any important words. Okay, so the goal, okay, this is why it was the optimization. It says what is the maximum area, so area is important there. Okay, but we want to identify any formulas that may be beneficial as we go through here. So it says a campground owner has 1,400 feet of fence to enclose a rectangular region on one side of the river. Okay, as you go, it might be helpful to draw a picture for something like this where it gives you a geometric shape. Okay, so it says rectangular, but we've got it along a river. So I'm starting with my river, and it says the rectangular goes on one side of it, and so here's what that would look like. And it said the river's on one side of the rectangle and the other threes are the remainder of that 1,400 feet. Okay, so when we're talking about enclosing something or going around with a fence, then it's really referring to the perimeter. Okay, so with perimeter, sorry my pen is trying to die here. With perimeter, we want to just add the different side lengths. So perimeter for this one would be, we've got two sides the same size and one that's different. Okay, so we've got 2W plus L. And if you interchange that and call it 2L plus W, it doesn't matter. Okay? What does matter is our first step on these types of problems is to plug in the number we're given and get one variable by itself. So we were told that the amount of space that we had was 1,400 feet. So that goes in for our perimeter. And our job is to solve for one of these variables, and I always go with the one that's easier to get by itself. So in this case, solving for L would be easier because 2W would require moving the L and getting rid of the 2. So we're just subtracting the 2W over and rewriting it. L equals 1,400 minus the 2W. And the reason we're doing that is because we want to maximize the area, and when we see max or min, okay, remember that means first derivative. Okay, so we got to come up with a formula where this is going to help us. Since it's area, we need our area formula of a rectangle. Okay, and that's just length times width. And by the way, on your test itself, don't stress about formulas for all this stuff. Okay, I had the formulas of your basic geometry shapes embedded into the test. Okay, my goal is to see if you know the calculus, not the geometry. Okay, so now we've got our length times width, and we're going to substitute. Here was our length. We're substituting it right in there. So A equals this whole thing, 1,400 minus 2W. Those grouping symbols are important. And then our times W. Okay, I want to simplify this before I do the derivative. It technically doesn't matter. That's just my preference. Okay, so here we're distributing that W through. 1,400 W minus 2W squared. And if you wanted to use X and Y instead of W and L, like whatever you're more comfortable with. Okay, but because of that first derivative, that's our next step. We're going to find that derivative of our area formula. Okay, so here we're just using 1,400, W goes away. Power rule for this one, minus 4W to the first power. And then we're setting that equal to 0 to go ahead and finish here. 1,400 minus 4W. Add that 4W over. Okay, a lot of people like to move the constant first, but it's actually easier here if you move the 4. And then just dividing by 4 to finish up. So W here would be 350. Okay, it says what is the maximum area. It doesn't ask for the width, it doesn't ask for the length, it asks for the area. Okay, but in order to find the area, we have to go back to our formula here and plug stuff in. Okay, so here we've got 1,400. Okay, minus 2 times W would be minus 700. And then times the 350. Okay, so this is just 750 by 350, and that's where this number right here comes from. Okay, let's try another optimization problem. This one, it's not a geometry problem. It's dealing with revenue. Okay, so we're looking at income here. It says a local group of scouts are collecting aluminum cans for recycling, and it has 1,200 pounds of cans already, and currently their rate for that is $7.50 per 100 pounds. That's important, okay? And then it says the group can continue to collect cans at the rate of 400 pounds per day. However, the recycling company announced that the price of aluminum will decrease by 0.15 per 100 pounds. And if the Scouts want to make only one trip to the recycling center, when should they go and how much income would they receive? Okay, so the when should they go, that's our variable. So our X is going to be the number of days. Okay, and then we have to come up with some formula using all these crazy numbers, but this underlined 100 is what I'm going to start with. Okay, because this is a rate based on 100 pounds, we need to make sure that we are changing every other number dealing with pounds to hundreds. So when this is 12,000 pounds, it's really 120 100 pounds. And no one would ever say that, but it's definitely how they wrote it here. We're going to do the same thing with the second number. That says 400 pounds, and that one's easier to change. It literally says 400, so that one's at least not weird. So these are the numbers that we are going to use, not the ones in the problem, okay, based on what the rate was. Okay, but let's talk about this formula. With money, the basic thing, how it works, if we're trying to get some total amount in terms of revenue, income, things like that, it's going to be formatted the same way every time. You have to have part of it dealing with money, okay, so some sort of rate, and then the second has to be dealing with amount, okay. So in context of our problem, our rate goes with our money per 100 pounds, okay, and there's two pieces that do that, and our amount goes with the pounds itself, okay. So we're going to write that out. Our income for us is just money per 100 pounds times the amount being, okay, the number of hundreds of pounds, right? And then we fill stuff in. I really recommend writing out what you need before you try to put the numbers in, because these ones are a little bit tougher. So now that we know this, we're going to go to work. Each one of these pieces should involve this X at some point. Okay, we have to have our variable here. So we have to incorporate this days somehow. So we're going to go just focus on the rate. So looking at our numbers here, it said currently our money was $7.50. Okay, so that was currently. This is what's happening already. No time has passed. This is our starting point. Then the second part, it says the price of aluminum is going to decrease by a rate of 0.15 per 100 pounds per day. So this per day is what's super important to focus on here, because remember we decided X was our number of days. So this is the part that has to have X on it. So our starting point was 750. And we're decreasing, so that means minus, and it's 0.15 per day or per X. That's our first part. Now we're going to do the same kind of thing over here. We're going to just look at the numbers that we have in hundreds of pounds. We already changed them to 120 and 4. Those are the numbers we have to use. But we have to go back to the reading to see which one goes with X to actually break this down. So here it says they have already collected the 12,000. So that was 120, our starting point. Then it said the group can continue at a rate of 400 per day. So that's that per day again, so that number has to go with our X. So we're starting with our 12,000 was really 120 in our hundreds. Okay, and here we're going to increase or decrease. We got to look. Okay, so it's collecting cans at this rate. That means we're adding more cans, so positive, and then 4 with our X. Okay, so this hundreds made it a little bit more tricky, so we got to watch out for those labels there. Okay, again, I like to, when I'm writing this, go ahead and simplify first. So I'm going to go ahead, FOIL here, first times first. And then we're going to do this all the way through. Okay, so that would be 900, and then 4 and 7.5 is 30, Okay, so that would be a positive 30x. Okay, then 0.15 and 120, that would be minus 18x. Okay, and then lastly, minus 0.6x squared. That's our income. We have some like terms that we can combine. 900 plus 12x minus 0.6x squared. If you prefer to write this in an order where the x squared part comes first, feel free, but you don't necessarily have to, because next step, we want to maximize the income. We are finding the derivative. Okay, so I'm going to write this I a little bit different so we can see that. And then constants go away. This is 12, power rule, minus 1.2x, and we're setting that equal to 0. Again, for this one, I'd rather add this 1.2, but if you want to move the constant first, you can. So 1.2x equals 12. That's not a 12. Divide that over. Sorry, my pen is dying, so it's not looking very good. And then x equals 10. Okay, so that's this go after 10 days, and then we just plug it in to this equation for our income that we came up with to come up with our final answer. So 750. Okay, 10 would be minus 1.5. Second part, 120 plus 4 times 10 is 40. Okay, simplify, this would be 6, this would be 160, and that's our 960 that comes out. Okay? Hopefully that helps, but the biggest thing you want to do is just practice on these ones. You can always redo some MyMathLab problems so you get familiar with different types of optimization. There's no guarantee that these are the types of formulas you're going to see on the test. It could, instead of a rectangle, be a circle, okay, or a cone. This type of problem could be related to amount, but not with pounds. Okay, so practice those types of problems so you get good at writing formulas. Okay, as always, on the test, show as much work as possible so I can see if you mess something up in your equation, if you did everything right after that. Okay.